Okay. Welcome to our second installment of the Watershed Stewardship website webinar series. This week we are doing stormwater and groundwater with our host, our presenter, Nikki. And this is hosted by Clark Conservation District. My name is Ashley. I'm with Clark Conservation District. And we work with community members to provide technical assistance on their land, as well as put on a number of workshop series like this. We also have a forester that provides a lot of really awesome resources to forestry landowners. This is being recorded, as with all 5 of our webinars, and you can find those on our website at clarkcd.org/watershed stewardship. An update for the 5 is that we are going to have the policies, regulations, and conservations is going to be occurring on the 22nd of this month of July. If you are joining us via the recordings, then hopefully you'll be able to see that and find those all on our website. Make sure to fill out the survey at the end of this recording. It should pop up for you all, and if you are watching this via the record on YouTube, then make sure to again go to our website and fill out that survey, and we have some awesome prizes for those of you that fill out the survey. So last week a sticker, and then this week we have your choice of either, hopefully you can see it, this awesome stormwater, managing stormwater booklet, or you get to choose, it doesn't show up very well, but this awesome rain garden handbook for Western Washington. So make sure to fill out those surveys, and then I will choose somebody to win that. So make sure again to register for each one of these webinars, or look for them on our website. So with that, I'm going to start the evening by turning it over to Nikki, who is from the city of Vancouver, and she will present tonight. Thank you, Nikki.
Thanks, Ashley. Let's see if my slides are gonna cooperate. Well, it's not. There we go. Okay. Hi, my name is Nikki Gio. I'm with the City of Vancouver. I work in our surface water management division in the Public Works Department. I'm an environmental scientist with the city, and my office is down at the Marine Park wastewater treatment plant. So if you've been to the Water Resource Education Center, I'm right across the parking lot there down by the river. So I'm going to talk to you guys about surface and groundwater, and we'll have a couple of breaks for questions, but if you have questions as I go along, I'm going to cover a lot of stuff, some pretty high level talking about surface and groundwater and the connections. So please drop your questions in the Q&A so we can make sure to answer those. So I want to start the presentation by just talking about my relationship to water. You know, I'm a scientist, and so I love data and, you know, looking at water quality, and that I'm very analytical. So that's my approach to water. And a lot of our regulations are, you know, numeric based standards, and that isn't the only way that water is valued, both in the United States and across the world. And so if we're going to talk about surface and groundwater, it's really important to, at the beginning, you know, frame this resource as what it really is in a lot of places, connection to cultural values and spiritual values. Water symbolizes purity, abundance, and it's pretty universally celebrated around the world. So these are just some of the cultural celebrations centered on water, and they cross all religious traditions, all the continents, except for Antarctica. But where there are people, they're celebrating water. We recognize the cultural importance of water. The value that water is life, that it's important to our communities, and that drives a lot of the numeric standards in science. We regulate what we value, but it has its own inherent implicit value. Water and water quality is important to not only life, biological life, but the quality of life in our communities. And so I just want to reflect on that at the beginning. A lot of cultural symbolism around water bodies, especially with Native groups. And so we just need to recognize there is a different context. I'm going to nerd out and go talk about science and regulations and all that stuff, but just want to take a moment at the beginning of the presentation and have that touchstone, that there are other frames of reference for water that are really important. So you guys talked about this in the last week's presentation, but in case folks are seeing this for the first time, I wanted to touch on the water cycle and the concept that there's no new water. Water is in different phases on Earth, but there's no new water. So the water that comes down out of the sky goes into the ground and recharges our water bodies that get evaporated and go back up into the sky. It's all connected. So the idea that it's one resource, it's a basic concept we teach kids in like 3rd grade, but it's easy to get separated, especially in urban environments, from this basic concept. There's a water cycle, that it's all connected. So this is kind of a fun, discoverwater.org is kind of a fun website that has some interactive elements. You can check out and look at the different phases of water. The little text box is showing you these different processes. So the way water moves through the environment, just to kind of give you a sense of the myriad of ways, that water cycles through on Earth. But it's a really important concept that we grasp, that there's just no new water. It's all the same water. It's one water source ultimately. So when we're talking about stormwater, and that's really the focus of my work, I've been an environmental scientist at the city for 5 years, but I've been doing stormwater work for longer than that, probably going on 20 years now. And stormwater is really important to municipalities, local governments, because of our changes in land use. So when you think about that water cycle, and you're seeing, this is actual aerial imagery from Eastern Vancouver, you're seeing the image on the left, that forested condition, that pre-development condition. And when you're having our rain events that we get in the Northwest are low intensity and long duration, right? So a little bit of water all day is more of our typical rain events. Well, when you have a forest canopy, it intercepts a lot of the water. That mist or that sprinkle, it doesn't get down through the canopy of the trees. If you have a big Doug fir in your neighborhood, that hangs out over the street or a sidewalk, it stays dry under there in a lot of rain events. And so in the image on the left, not a lot of stormwater is reaching the ground. A lot of it stays up in the canopy. It's evaporated or absorbed by the vegetation, and it cycles through again. In the developed condition on the right, what we're seeing is, the roads, the roof areas, patios, driveways, hard surface. That does not receive stormwater the same way as the forest, right? That water in the developed condition, the rainwater runs off. And so not only is it liquid, instead of having in the forested condition where it's evaporating and cycling through quickly, in the developed condition, we have runoff, liquid water that needs to go somewhere. So it's being conveyed, it's being passed through pipes down to our surface waters, the streams and creeks that you guys were naming in the watersheds poll. And so that water gets to those streams a lot quicker and a lot more often in the built environment in this developed condition. And when the water is running across, it's staying warm. So temperature is a big issue for water quality. It's also picking up a lot of debris off of roadways, chemicals, fertilizers, all of that, because it's staying in that liquid form. It's bringing that energy across the roof surface, down the driveways and the roads, into storm drains and carrying it either to stormwater facilities, directly to surface waters, a variety of places. But this is a very common mode of development in Vancouver. A lot of our neighborhoods look like this now, high density, pretty small lot sizes. So we get a lot of hard surface per building lot area in the developed condition in Vancouver. That's kind of the nature of our modern styles of development. So I wanted to talk a little bit about our geology, and there was some interest in the poll about that. So it's really important in Vancouver to talk about the connection between stormwater and geology, because we are underlain by the same aquifers as Portland. We're on the Troutdale Formation, but when the Missoula floods came through and carved out this valley, they brought the surface water that much closer to the aquifer. So we have, a reduced amount of geology between the surface water and the groundwater that we're drinking. In Vancouver, we get all of our drinking water from the underground aquifers. And so when you see this valley and you think of it in geologic time, there were all these layers built up over the aquifer. The Missoula took them down really quickly, and then we continue to have, erosion, the moving channel of the Columbia and the Willamette. We see some of that vulnerability with our aquifers being exposed. So this is a great image. If you go to earthsphere.net, you can find a couple of different versions of this image, and it's just really interesting to reflect on how the geology in this area really makes us more vulnerable in our groundwater protection efforts. I wanted to show the cross section because we were looking down at the valley, but if you look in a cross section, you can see that we have a lot of different layers of geology in the Vancouver area, but we have some different gravels and different types of rock in there. So we have, you can see in the image, there's the aquifer layers, then there's these confining units, the upper confining unit, the lower confining unit, and the Sandy River aquifer. So we're tapping into a lot of that for our drinking water, but these black lines are wells in the city of Vancouver. And you can see that we do have, it's not all of the wells, but you can see that we do have wells in that upper Troutdale, which is right under the Orchards formation, which is really gravel and coarse gravel. So there isn't a confining unit over the upper Troutdale. And so everything that runs across that surface, that upper Orchards aquifer layer, has the potential to get down to the Troutdale. And if you follow the upper Troutdale across, you can see that it's connected to the Columbia River. We start to get on the Columbia slope, we start to get those seeps and springs, that convey some of that water directly out. So that concept of one water is very present here. Whether the water is moving down or it's moving laterally, it's all one water cycle. So I think it's interesting to see the cross section and understand that it's not just solid rock and then a bathtub underneath. There's these layers. There's a nuance to it. So stormwater in Vancouver, a lot of it goes into infiltration. It goes down into that upper Orchards gravel. It's really easy to get rid of stormwater that way, but that's also where we get our drinking water. So in the last image, I'm showing you the black lines. This is spatially where those drinking water stations are in the city of Vancouver on the left, and then Clark County, this is the PUD well map on the right. Just so you have an idea, for the city of Vancouver in particular, the wells are spread out through the city. You know, there isn't like, oh, that's the one place where we, you know, keep our clean drinking water. We get drinking water across our whole city limits, essentially, and a little bit outside of our city limits. So it's really important how we manage our stormwater, especially where we're infiltrating, to protect those drinking water sources. And the same can be said for Clark County. A lot of their drinking water wells are in less dense areas. So maybe there's less vulnerability there, but you can see they're spread out through Clark County. There aren't just like, well, here's the one area of drinking water wells. They're really in several different watersheds in a lot of different areas. So protecting drinking water wells is a big issue. And we share, there's a dot down there by Vancouver Lake that we share with PUD, and you know, there's a lot of, in terms of that, looking at the Missoula cut through the valley, there's a lot of interplay between those groundwater sources. So they're not confined, you know, between the different utilities. We're all getting water from the same places. And so that brings up the overlap between the Safe Drinking Water Act, which regulates all those wells, and the quality of water that we provide to customers, and the Clean Water Act, which regulates the surface waters and our stormwater permit in particular. So the city, because we provide drinking water, we also process wastewater and stormwater. We have all of those utilities. We really integrate these two sets of regulations. Not a lot of cities have to do that. There's a lot of cities that use drinking water from surface waters, like Portland in the Bull Run watershed, the part of the city that draws from that, that's a surface water. So they don't have to, you know, worry about these two in that area. But for the city of Vancouver, it's a big issue. And where stormwater is easily disposed in those gravelly soil layers, you know, we put in a drain and it just, you know, drains very quickly through that gravel layer. It's moving towards the drinking water wells that much quicker. So we really are cognizant of these two sets of regulations. And if we're going to dispose of our stormwater to the ground, we need to be able to integrate those two and meet the needs of both systems. So that's what our water resource protection program is about. And sometimes I think water resource protection sounds kind of vague or confusing. This is what we're talking about. It's water resources because it's all one water, right? The stormwater is the same as the drinking water. Like both of them are in the same system. So we need to really protect all the water resources. So I wanted to talk a little bit about climate change. This has been a hot topic in the past. There were a couple of folks interested on the poll as well, but I want to talk about how climate change, especially in Washington, the Center for Science of the Earth System has a climate impacts group at the University of Washington. There's a ton of great information in there on the changes that climate change will bring to our water resources. One big issue is water withdrawals and water conservation and outstripping our supply. That's a big concern, especially when you're thinking about climate change. Conflicts, you know, demands for water resources, especially like in Eastern Washington, when you're talking about ag, you know, a tremendous amount of resources going towards that. Water quality degradation, especially as we have temperatures rise and have offsets to our water cycles, it's a possibility. A big issue for the city of Vancouver specifically is the idea of more intense and more frequent droughts and floods. Both ends of that spectrum are not, our system is not designed to have tolerance for those extremes. So if we start having more of like these June downpours that we've been having this year, you know, heavy rain events, we get a lot of rain in an hour. Our system really isn't sized for those big events. And similar with drought, you know, if we have our surface waters, you know, Burnt Bridge Creek, if the water levels get down really far, that can be a big issue for stormwater as well, because we don't have mixing of the stormwater. It puts more of that warm stormwater runoff directly into the water bodies, which can be really a negative impact for ecosystems and habitat. And I just wanted to share these two images of the offset in the models for the water year. So when you look at the Columbia River at the Dalles, If we're thinking about the most extreme shift is the red line in the model. The Columbia River, it's a little shift. We get a little more of that water level in the winter, but then the peak, coming in on the other side is a little bit lower. But when you look at Yakima, climate change has a potential to totally shift their water year. Instead of getting a lot of their peak runoff in the summer, they could be getting it in the winter, and that could really throw off a whole ecosystem. So the image here shows the historical watershed classifications where we have this transitional system between snow and rain. We get a lot of the snow melt runoff in the state of Washington, so snowpack numbers are always really important. But as we transition to climate change and warming temperatures, we see going more towards losing that snowpack and being very rain dominant. So we kind of lose our savings account for water resources. A lot of our recharge and base flow comes from those clean, clear snowpack runoff. So if you are interested in this, I really recommend the University of Washington and checking out some of their resources. It definitely will have an impact on water resource protection. So one of the other big challenges for the city of Vancouver, just in terms of the stormwater utility and managing that system, is that we have a lot of, if you think about like downtown Vancouver, we have conveyance systems that were set up to prevent flooding. So we put in storm drains and got that water to the river as soon as possible. We just put in big pipes and we just gravity feed it right down to the river directly, especially west of I-5. A lot of that goes straight to the river. But again, it's not really sized for large, intense rain events. It's really sized for, that long duration, low intensity storm runoff. So we're in terms of preventing flooding, a lot of our system is substandard. And then when we're infiltrating a lot of our stormwater and we're trying to get, our runoff into the ground, we have to think about seasonal high groundwater. And when the groundwater comes up and that recharge refills, there's a possibility of that stormwater coming into contact with the groundwater. And we want to maintain a separation there. We don't get the kind of like treatment down through that gravel aquifer layer if the seasonal high groundwater is too high. And I just wanted to show some images of typical stormwater structures. This is kind of the meat and potatoes of the stormwater utility. On the left side is a catch basin, which is the engineering term for a storm drain. And you probably see these, on your streets, in your neighborhood, downtown. The downtown folks did a storm drain mural project a couple of years ago. So if you've seen some of those paintings on the ground, they're trying to draw attention to storm drains and just raise awareness. They're kind of something that you don't notice until you know what they are, and then you see them everywhere. It's one of those things like, oh, it's another storm drain. And most of our storm drains in the city of Vancouver in particular go to infiltration. And so what that looks like in a lot of places in the city is this dry well. So the picture on the right, it's a concrete cylinder with holes in it. It's very low tech. It gravity feeds out the stormwater runoff, at a controlled rate. It allows us to capture sediment and trash, anything that we don't want getting into the groundwater. It's not a treatment system, it's more of a water disposal system. So we stick the water down in there and it fills up, and then it slowly leaches out into the groundwater. And that's where we have to think about seasonal high groundwater. If the water level comes up and the rock around the dry well is saturated, the stormwater can't get out. So then we end up having more flooding and backups. There are several places in the city that drain directly to surface water. So the image in the middle is a pipe that goes to the Columbia River. So sometimes our storm drains, gather all that runoff and then just take it to a really big pipe. This is one built into a culvert, and you can see it's got a base flow that's just water running. A lot of these are called outfall pipes. A lot of our outfalls are along the Columbia River, and they intercept groundwater seeps and springs. So there may be water trickling out of those things, 10 months of the year. There's a lot of groundwater lateral movement towards the river on the Columbia slope. We do have outfalls on Burnt Bridge Creek. They're just smaller scale. They drain smaller areas. We have a lot of good infiltration in the city, so we don't discharge a lot of our stormwater directly to surface water bodies, which is unusual. A lot of local governments don't have infiltrating soils. A lot of Western Washington doesn't have infiltrating soils. So most stormwater systems are the catch basins and the outfalls. We're collecting the water and then we're getting it to the water body as soon as possible. So that's more of a standard stormwater type system. And so we have this extra element of infiltration. But the universal issue with stormwater systems and managing stormwater utilities is maintenance and aging components. Some of these pipes, especially downtown, they were put in the 1920s. Some of the drains I've seen were put in around the turn of the century, like just very old systems, just trying to prevent flooding. And so when you think of this distributed storm system we have across the whole city limits, that's all aging, that all needs maintenance. It's a pretty big challenge for us to keep track of all those structural components and maintain them in a timely manner to prevent flooding and get the most water quality treatment that we can. Okay, I wanted to show this video of a stormwater outfall. So I mentioned the outfalls. This is actually an outfall in the Puget Sound. And in the Seattle area, there's a lot of storm systems that combine with sanitary sewer overflows. And so some of the outfalls are much larger because if the sanitary sewer system floods, they're trying to get the water out of the treatment plants. And so they go to the Sound. There's a whole different set of regulations around wastewater treatment that I won't get into, but just to say that, this is a pretty large outfall. And the idea with this is if you go to tox-ic.org, you can see that there is a whole campaign thinking about water quality in Puget Sound. There are several videos of different outfalls in the Sound. There's a woman who gets in her scuba gear and goes down in rain events and takes these videos of these storm outfalls. So we don't have the same kind of circumstances that are in this video, but it just really clearly and quickly illustrates. This is a 4-hour first flush rain, which is when we've had a lot of dry weather, and then we get that first heavy rainfall that kind of washes the streets down, kind of washes all the dirt off the streets. So I'll just play this really quickly. So you can see, there's a lot of sea life. There's fish darting in and out. There are anemones on the head wall itself. And then you start to see this kind of yellowy brown color. And now most of the fish are gone. And as the storm goes on and this water keeps coming off the pavement, it gets blacker and blacker. And what you're seeing in that image is untreated stormwater from the roadways that's coming directly into Puget Sound. So the fish swim away, all the sea life wants to get away from it. It's very hot compared to the Sound. The stormwater runoff is really warm, and it's full of pollutants from roadways. So a lot of the research in looking at that particular in Seattle, looking at that road runoff, is there's a lot of brake dust and tire fragments. When your tire tread wears off on your tires on your car, those fragments, those particles of rubber end up in the water, the storm water that washes out into the Sound, plus all the leaks and drips and everything that comes off of your car. So we have that cocktail of material that ends up in our stormwater, and a lot of places, in most places, it goes straight to surface waters, just like this video is illustrating. So if you're interested, I encourage you to check out toxic.org and some of the resources and information they have on the website. It's really, really interesting. And I wanted to talk a little bit about, so you see that dirty water and, fish can get away from it, and kind of thinking about like, well, it's this one pipe in the Puget Sound, it's not great, but it doesn't happen all the time. And there are a lot of water quality impacts beyond the visual plume that we're seeing. So even in smaller rain events, you're still getting that mix of wastes in the stormwater. And this is research out of the Washington State University center up. They have an office up in Seattle, and they're looking specifically at runoff from the interstate system and capturing it and testing it on fish and finding out what are the impacts of stormwater and what can we do, more importantly, to mitigate those impacts. And so where we see a lot of coho mortality where there's stormwater impacts up in Puget Sound, we also see these sublethal effects. So this is comparing filtered stormwater to unfiltered stormwater. And you can see that, the fish, they die, a large number of them die at this stage. This is their Longfellow Creek experiment where they're looking at 50 days of exposure, which, if they were juvenile fish in the stream, it would probably be around that same type of exposure because of the concentrations of the stormwater. But some of them don't die outright. 30% of them aren't dying, they're abnormal. And so that means they may have smaller hearts, they may have malformed gills, they may not have reproductive structures, they may have amorphous reproductive structures. So even if they don't die, they're still suffering from the pollution that's in the water, and it makes them unable to breed. It makes them kind of non-viable. So stormwater definitely has a lot of contaminants in it, and the filter that they used in this experiment, and something that we're using widely in Western Washington, is a simple bioretention or rain garden gravity filter that's a sand compost mix with plants on top, and the stormwater just travels through that acts as the filter, and the water on the other end ends up having mortality rates for the fish that are more along the lines of what you'd expect to see in nature, in a sort of baseline stream that's got just run-of-the-mill mortality. So that kind of stormwater treatment is growing in popularity. It's been the best practice for about 15 years. The state of Washington required it in the last stormwater permit. So we have been implementing it in Vancouver for a long time. And we've retrofitted a lot of our system with these filters, in an attempt to improve the water quality to those surface water bodies where we're getting that direct discharge. But Jennifer McIntyre is the scientist, the PhD who's done a lot of the research. She has great videos. She's done work with the Nature Conservancy and a lot of other groups in the Puget Sound. So if you're interested in learning more about coho, salmon, water quality, really encourage you to check that out. And I wanted to talk a little bit about, the concept of the water cycle, and it's one water, right? And so septic systems play a big part in that water cycle, especially in the city of Vancouver, because we have these great gravelly soils, where you can just put a lot of water in those soils and they'll just keep draining. So septic tanks, if you don't have a septic at home, they're pretty simple systems, really. They have a box, a tank, the septic tank, that has a baffle in it that separates the solids from the liquids. You get some biological digestion in there. They also need to be cleaned out routinely, but then they gravity feed into what is displayed here as it says the effluent disperses, so it goes through a drain field. That water, once the waste has been settled out in the tank, the water itself goes out into the ground and just infiltrates. Very similar to how we're disposing of stormwater, you can dispose of wastewater, and you have that treatment mechanism. But the hard part about septics in this area, there's a lot of them. There's a lot in Clark County. but our good draining soils can mask some of the functional issues of septic systems. So when you have a septic that's not working, generally you will know because your yard will become a cesspool. It will back up, and that's when you call, to have the system fixed. But routine inspection and maintenance is super important to keep those systems working because the gravelly soils may not back up. If your tank isn't working effectively, you could be leaching solids and other waste out into that drain field. And with the really gravelly soils, it could just be, traveling down to groundwater. So it's really important to make sure that you, if you get the postcard from Clark County Public Health, that you follow their requirements for inspection. The city also has prohibitions on septic tanks where they can be sited. We don't allow them near the drinking water wells, but that's not a lot of square footage for the city. And you want to make sure that if you need to have repairs or if you need to have an inspection, you use a certified provider and you use someone that's in the preferred pumping program. And that would be the same if you're on PUD or if you're in the city of Vancouver. You just want to make sure that you're working with somebody who's really experienced and knows how to service those systems. So some really high level kind of do's and don'ts for water quality, because if the water quality is poor, it can potentially impact our drinking water sources. You want to avoid overloading your septic system. Your septic tank isn't meant to have a ton of water flushed through it. It's trying to settle out the solids and digest the wastes. So if you can stagger your wash days, make sure that you repair leaking fixtures. If you have a leaking toilet or a faucet that runs all the time, that's just adding more water load into your tank. And so get those repaired as soon as you can. Use household cleaners in moderation. Don't dump extra household cleaners down your septic tank. If you have a septic tank, you probably already know that, but a lot of household cleaners can affect the biological life in your tank really negatively. So you want to make sure to use the right products and follow the label. So that means using it in the right amounts. Make sure you keep records of where your drain field is. I've talked to so many homeowners didn't know where their drain field was. The tank has a lid on it, so you can find it really easy. But if you don't know where your drain field is and you put a shed over it, or you put an addition to your house over your drain field, that's not a great idea. You need to be able to access that drain field. You need to be able to repair it if necessary. And so know where your drain field is. Keep records of that. Keep records of your repairs and inspections. And again, use somebody that's certified. You definitely don't want to pave over your drain field. You want to avoid plantings where the roots can get down into your drain field and crush your pipe. You don't want to use additives or boosters or enzymes. They're not going to give you anything that is not already in that tank, and they can be really detrimental to water quality. Of course, keep trash out of your drains. And if you have a septic, you probably know that. You can't put dental floss and Q-tips down in there. They don't go away. A lot of those products have plastic in them now, and so you can't flush that stuff. And any kind of household hazardous waste, whether it's cleaners, pesticides, paints, any of that stuff, don't wash it down the drain. Take it to the local household hazardous waste drop off. Clark County has several places you can take that material and they'll safely dispose of it. So those are some tips for septics. And I want to talk a little bit about stormwater management, but should we take a break for questions? Because it's already 7:45. Ashley, are you?
I would continue, Nikki. We don't have any questions at this time, but
Oh, great.
please
Okay.
add any questions into the question box.
Yes, please ask questions. I'm happy to answer any questions. And I know I'm kind of running through a lot, so just definitely let me know. So when we're talking about stormwater management, the city of Vancouver has had a stormwater management code and requirements for a long time. We passed our first ordinance in 1993. We really started seeing projects implementing these measures in around 96. So keeping an eye on protecting water resources, our drinking water in particular. But so on the left is sort of stormwater 1.0. So these are swales, grassy swales. It's another kind of thing that once you know what they are, you start to see them everywhere. So these, you'll see these a lot of times at apartment complexes, commercial centers. This is off of East Mill Plain, but they're mainly there to take stormwater in. You can kind of see there's a darker green stretch of grass. So we're trying to get the water to kind of do a little S curve so it soaks into that grass. So it settles out and we can get as much of the grit off the parking lot settled into that swale where it can be recovered. And the swales work really well because it's turf grass, which is, very standard type of material to manage, pretty low tech, simple system. But from us implementing that for a couple of decades, we realized we weren't getting water quality improvements that we needed. And so we've switched now to more bioretention, which is the image on the right. And so you can see it's very densely planted with these trees, shrubs, grasses. There could be flowers. And the idea is that those plants will uptake the nutrients and the stormwater to help that water get clean. There is a lot of filtering that happens in bioretention through the soil, but the plants also uptake a lot of that, the pollutants that you think especially about nutrients. If somebody's over fertilized their grass and that washes into a storm drain, these plants can absorb that rather than washing it through the system. So this is stormwater 1.0 and stormwater 2.0. And the state of Washington said, yeah, that's not really working either. You're not getting the water quality outcomes that you need. So now we have low impact development, which goes beyond treatment, flow control. This is looking at development styles. So it's kind of zooming out to that 50,000 foot view and saying, well, if you had less pavement area, you'd have less stormwater. And so we're trying to get, in low impact development, we're trying to get the built environment to function more like that forested environment. And so this is an example of a design on the top right that's showing a typical subdivision. And then on the bottom right is showing low impact. And you can see they've reserved a lot of green space. The lots, some of the lots are smaller, but it's the same number of lots. The impervious area, the roadways and the pavement, it's a similar amount, but it gives you more green space to infiltrate that runoff and provide for a lot of other quality of life benefits. So we're trying to get the built environment to follow this diagram, and we want to evapotranspirate, which is what the plants do. Evapotranspiration, they either absorb it or it just evaporates off their leaves. We want around 50% of the stormwater to do that again. And so we need to integrate those aspects into new kinds of subdivisions. So that's the standard now that Vancouver is implementing. We've had the regulation on the book for a couple of years. It was very controversial in Western Washington to adopt this, but we are underway. We're doing that. Oh, here, and I've highlighted, you can kind of see the amount of green space. You end up with a similar amount of roadway, but you have a lot more green space. And so when you're thinking about that green space, and low impact development uses green infrastructure. And so that's not only using bioretention, but it's also setting aside stream corridors. It's providing for more open space. There's a lot of quality of life benefits that come with that. So this is a graphic out of the Center for Neighborhood Technology in Chicago that just says, for these different green infrastructure practices, green roofs, bioretention, water harvesting, they have other quality of life benefits. They can reduce CO2, they can reduce energy use, they can improve overall the aesthetics of the neighborhood, they can increase habitat. So beyond just the stormwater, outcomes that we're after, there's a lot of other benefits of green infrastructure to the community that make it a really great solution for stormwater management. And on a site scale basis, instead of looking at that whole neighborhood, when you look at an individual lot, what we're talking about is rain gardens and pervious pavement. And so if you build a new home in Vancouver, these are likely the requirements that you're going to have in a new home. So the rain garden will take the runoff from the roof area, any hard surface. So rather than having your downspouts tied into the curb and running your stormwater out to the street, we're going to treat it through the bioretention soil and try to infiltrate it. And the pervious pavement, similar, instead of running that water off your driveway to get it to the street, we're going to try to infiltrate that runoff. There's a lot of water quality treatment in pervious pavement, kind of similar to the septic tank. It develops kind of a biological film in the bottom that can absorb grease and oil and nutrients. So pervious pavement is really helpful for water quality treatment. And so I wanted to wrap up the presentation talking a little bit about what you can do to help. And there are a lot of things that the average homeowner resident can do in our community to help. I really encourage you to check out some of these resources. Stormwater Partners is a regional stormwater outreach group. We have a great website. It's a lot of us working together down here in Southwest Washington. And there's videos, there's different handouts, there's categories for businesses, homeowners, apartments, really great resources there. Information on pet waste, just everything you can think of. We just redid the format. Eric, who was a presenter last week, worked really hard on this and it turned out really great. The Puget Sound Natural Lawn Care Project has a series of YouTube videos that are great. If you are thinking, sure, yeah, I would like to use fewer chemicals in my yard, but I can't get rid of this moss. Or what about these slugs? I can't live with these slugs. Like, I want to protect the environment, but I can't deal with this. Check out the Puget Sound Natural Lawn Care videos on YouTube. They have really specific ones. Grow Smart, Grow Safe is a website that tells you specific products. So it'll tell you active ingredients and name brands. If you're to that point where you're saying, well, I've got something I really like for weed control, what are the other options? Grow Smart, Grow Safe is a great resource for that. And then Don't Drip and Drive is a website dedicated to figuring out if your car has a leak, what that leak is, how it affects stormwater, and what you can do. There's a coupon on there for $50 off. I think it's $50 or 10%, something like that, off of service to fix your car. If you can't fix your car, if you have a leak, you have a leaky car, and you're just, I'm stuck with it, I've got this repair I can't afford, it's really important to use dry absorbents or even a spill pan or a sheet of cardboard, something to contain those leaks and drips, because those leaks and drips across this, all the pavement that we have on our public streets, it ends up being a lot of chemicals in our stormwater. So fix that leak, fixthatleak.org, fixthoseleaks.org actually. And I wanted to talk a little bit about upstream good housekeeping, spill cleanup, and specifically landscape debris. These are real pictures from the city of Vancouver. There's a picture of some leaks in the street from a car that's leaking all the time. It's very easy to put some kitty litter down, sweep it into that grease, and sweep it up and put it in the trash. It's an easy thing you can do. This picture on the left is paint in a dry well that's been washed out from a catch basin. Don't wash your paintbrushes in the street. Please, please don't wash your paintbrushes in the street. It's very hard to get the paint out of the storm system. It's better to put it down the sink. You don't want to overload your septic system, but our wastewater treatment plants can handle that amount of runoff. And the landscape debris, we're talking about leaves, the moss off of your driveway. When you wash or blow or push that stuff into the street, it ends up in our storm drains and clogs our system. So keep it clean upstream will help us out tremendously in managing stormwater. And I know Eric covered most of these last week, but car washing, go to a professional car wash. Please go to a commercial car wash. That's the simplest, most straightforward solution. Most of the commercial car washes are recycling water at rates that you just can't achieve at home. I know it's $5 to go to Katy, but it saves our stormwater facilities from having those soaps and grease and oil All the stuff you're trying to get off your car, we don't want in the storm drains. We don't want it in Burnt Bridge Creek. We don't want it in a drinking water system. So please use a commercial car wash and pick up after your pets. A lot of our water quality issues include bacteria, and a lot of the testing that we're seeing indicates dogs are a major source. So clean up after your dog, put it in the trash. You got to bag it and put it in the trash. You got to have both. So if you have a spill and accidents happen, that happens all the time. Call us so we can help, so we can come triage, so we can come clean up downstream and prevent a small accident from becoming a much larger issue. If you're outside the city, you can call Ecology directly. And even in COVID, they are taking spill calls and responding. So we want to protect the environment. And like this slide says, we want to leave that legacy of clean, healthy water. If you have questions or concerns in the city of Vancouver, you can always contact me directly. This is my direct phone number and my email. I am happy to take questions and hear from our residents. And just remember, only rain down the drain. That's it.
Thank you, Nikki, so much. Let's all give her a quick round of applause in our house. And yep, we hear that. And then we are coming to the end of our hour. So feel free to sign off when you feel you need to. If it works for you, Nikki, we'll stay on for a little bit and just answer some questions. So feel free to stay on and continue to keep putting some of those questions into the question box, and we will go through them. And as you guys close out, just remember that to fill out that survey, you'll get some awesome prizes. You can kind of see them. And fill out that survey if you end up watching it online on the recorded version as well. It just helps us know who has been with us. And remember, if you attend all 5, which I am noting by those surveys that you fill out, then you get some awesome prizes and become a watershed steward. So with that, I'm going to ask a couple of the questions, Nikki. So let's see. Do different aquifers have different fill rates?
Yeah, that's a good question, because I think people conceptually imagine an aquifer is an aquifer is an aquifer, but the geology is not consistent, and it's not even within the same aquifer, it's not all uniform, So when I showed that cross section of the different layers, you can see how the layers kind of came and went. There was a lot of variation in that. So a lot of our aquifers here do get base flow from snow melt. The Columbia River provides a ton of base flow recharge for our aquifers, and the Columbia gets a lot of snow melt. So there's a lot of interplay between aquifers. It's that idea of like a bathtub underground, there's just this pool underground that fills and empties, is a little oversimplified. So there may be areas where we get really quick recharge. There may be other places in the aquifer where we've got, confining clays or something like that delay that process. And through the state of Washington, it definitely varies. The recharge rates really vary. And everything that we can do, that's why it's so important to infiltrate stormwater, because that's just more of that water being recovered and sent down to the aquifer. If we can treat the stormwater and get it clean, it really helps to recharge the aquifers.
Thanks. I think the next one kind of goes a little bit along that, and you probably already answered it. But what is the ideal way to manage gutter water coming off of your roof? They said we have one that drains into a sloped sidewalk and then grass. So I know you talked a little bit about rain gardens, but is there any other things people should think about if they have, gutters, and how to deal with that?
Yeah. So there's a couple of things to think about. A lot of downspouts especially in the city of Vancouver, they're required to infiltrate on site. That's been a requirement for a little while. So you need to get that water underground and soaking into the ground. So a lot of newer homes will have an infiltration trench underground, which is similar to a septic field, where it's a rock trench with a 4-inch pipe that has holes in it. And so you take that runoff from your downspouts and you put it through that rock trench and let it soak into the ground. A great alternative is a rain garden, where you're getting that water at the surface and it can evaporate off of the plants. The plants soak up some of the water. The rain garden is a depression so that you hold water. You just want to avoid holding water over 48 hours. That ends up changing the soils. But the main thing to think about with a downspout system, whether you have an infiltration or something that's going to the surface, is everything that's in your gutters ends up in your downspout and ends up in your stormwater system. So keeping the moss and the leaves out of your gutters and not flushing that stuff down, but cleaning it out and putting it in your trash will really help prolong the life of either your infiltration trench or your rain garden. Another thing to think about, in terms, you've got the debris, right? So now you're cleaning out the moss, cleaning out the leaves. You really want to avoid putting pesticides on your roof. So if you're putting a lot of moss killer on your roof and then you're trying to have a rain garden, those pesticides will affect your rain garden. So look at better options for moss control. The zinc strips are a good option. But when you're going up there and putting Moss Be Gone on the roof twice a year, that can really affect the plants. And if your downspout happens to connect into the curb, like an old style weep hole is what they're called. If your downspout connects to the street, all of that stuff still applies because your downspout is probably going into the stormwater system. And you just want to avoid that pollution, whether it's leaves, moss, or the pesticides.
Awesome. Great information. I think we'll do 2 more questions and then wrap this up. So this person said, I have read that septic systems should not be used for lots smaller than 1 acre. Is that correct?
Well, the lot size, the septic systems are sized based on the house size, not the lot size. And so, if you've got a little ranch house like mine, I've got 1 bathroom and 1,100 square feet. I'm on a 1/4 acre, I could have a septic system. It's not, I don't need that much wastewater disposal. If you've got, some of the houses we're seeing built now are 5,000, 6,000 square feet, 4 bathrooms, you're going to need a lot of area for that wastewater. So it's the size of the lot is less important than the size of the house. And a properly managed septic system, that's cleaned out regularly and functioning properly. Depending on your soils, you may not need that much area. You may have a great gravelly soil that just infiltrates that runoff, that wastewater. So it's more related to how much wastewater you're generating than your lot size.
Awesome. And I know that this person had a follow-up question, and I just encourage you to, I'm going to hold off on that question for the policies section, because it's about, how much area needs to be around stuff. And I think that would be a great time to come back and we can talk. You'll hear all about that stuff later. And so for the final question, what chemicals do they use to clean and recycle water at the car wash?
At the car wash, and it depends, commercial car washes, a lot of times they have their own, magic box. Everybody's got their own proprietary secret sauce of what they're using. So it's not apples to apples, it varies, but a lot of times what they're doing is they separate out, they have like a gravity system that separates out the grit and floats the oil, that separates out the soap. Some of them actually have an activated carbon filter, so that water is getting really cleaned and polished before they reuse it. So it varies depending on the car wash, but there'll be some kind of solids system, something to remove the oil and the floatables, and then there'll be something to polish the water quality. So it depends on the system. The great thing about commercial car washes is that they're conserving so much of that water. They waste almost no water. It's not in their business interest to just pour the water down the drain. They recover and reuse as much as they can. So depending on what car wash you go to, they may be recovering 80% of that water. And it's a huge conservation benefit, just to be able to not draw in tons of potable water to wash cars, to be able to recycle that water and keep reusing it is a really great benefit of a commercial car wash.
Awesome. Well, thank you everybody for joining us tonight. And as you leave, hopefully a survey should pop up. If it doesn't, make sure to go to our website and get that, or if you missed it. And by filling out the survey, you get entered to win one of these awesome books. So just strongly encouraging that. Feel free to send me emails. My emails on all of the promotional stuff that you should have, all the emails that you got for this event. So let me know if you have any feedback or questions, or if there's any topics that weren't covered tonight that you'd like to see or hear a little bit more about in the upcoming weeks. And hopefully you guys have all had a chance to check out Eric's presentation last week. And if not, again, check that out online, and we will be joined next time by Tori to learn about plants. So feel free again to send me any questions you have ahead of time so that we can help her make sure to tailor the presentation to you all that are coming. So again, thank you so much. Give a big round of applause to Nikki. She did a great job, and we look forward to seeing you all next time. So thank you.